Please excuse my hair. It is crazy hair day here at school today. So you might see my hair getting bigger and bigger as the video goes on. We'll see what I look like by the end of this. So stay tuned for that. So today we are working on lesson 4.5. So we are going to be using all the operations, add, subtract, multiply, divide with those decimals. So we're going to have to look for our keywords and decide which operation we need to do in order to complete the problem. So let's look at task 1 here. So task 1 tells us that Harold bought 3.5 pounds of red apples. That cost $1.79 for every pound. Per is another word for every. So every time he bought a pound, it cost $1.79. The second pound cost another $1.79. The third pound cost another $1.79. And that half pound cost half of that. So we could add up $1.79, $1.79, $1.79. We could divide $1.79 in half and add that on. But repeated addition, so here's 1 pound of the apples is $1.79. The second pound, $1.79. So I know when I'm doing repeated addition, that multiplication is often an easier way to get there. Remember, this one only has half of it. So I would have to divide this first and cut it in half, and then I'd have to add. So I'd actually be doing more work than if we just multiply the problem. So we have 3.5, we're timesing by 1.79. I know 3 is a bigger number than 1, but I'm still going to put the 3.5 on the bottom because it has fewer digits. So make sure you have a paper and a pencil and are completing this work with me. So we have $1.79 and we don't have to line up our decimals. Right now, we're just ignoring it. Pretend like you are doing 179 times 35 and then worry about the decimals at the end. Okay, so I want you to pause the video and see if you can finish this problem and then come back and check your work with me. Okay, so 5 times 9 is 45. Carry that 4. 5 times 7 is 35 plus 4 more, 39. 5 times 1 is 5 plus 3 is 8. So I want to cross these off so I don't accidentally use them again and make sure I get this placeholder because now I'm multiplying by a number that's 10 times bigger. So I've got to have my answer be 10 times bigger. So 3 times 9 is 27. 3 times 7 is 21 plus 2 is 23. 3 times 1 is 3 plus 2 is 5. Okay, so we've got 5, and there's 16, 9, 10, 11, 12, and 6. So now I need to go look at my decimals. I have 1, 2, 3 decimal places. 1, 2, 3. So he spent $6.26, or we can round this to the hundredths place like the pennies. 5 is a big, strong number. It is closer to the next number. So that's going to push this 6 up to 6.27. So he spent $6.27. So let's go ahead and look at our questions for task 1 here. So, forgot my hair looked like that. Okay, so first, let's get an estimate to make sure we're even on the right track. So estimate the product by rounding each number to the nearest whole number. So if I round 3, look back behind, the 5 is big and it pushes the 3 up to 4. Here's my 1. Look back behind, 7 is another big number that's going to push that 1 up to a 2. So 4 times 2 is 8. So our answer should be around $8. Sorry, I've got a little sneeze. Okay. But I know my answer should be less than that because both of these numbers are smaller than 4 and 2. So my answer should be less than 8 when we're done. So in order to do this problem, what operation did we have to do to solve that? And now we're going to actually solve the problem. So we did 3.5. Oh, sorry, the money, I can see the money is over here. So yeah, yes, we're right. So we have 3.5 and we times that by $1.79. And our answer goes here. Remember, it asks us to round it to the nearest cent, which is the hundredths place. Whenever we're talking about money, it should have 2 decimal places. So since the estimate, was it close or was it not? So look back up at our estimate that we got here and decide if it was reasonable or not. And then tell me how much money Harold spent on the apples. So go ahead and finish up those questions on task 1 and then head over to task 2 when you're ready. Hey, so Taven hiked 6.1 miles in 2.5 hours. Taven says that he can find how fast he hiked by subtracting. So let's think about if he is correct or not. So we know his total. So he started here at 0 and he hiked to 6.1. And he did that in 2.5 hours. So if I put a timeline up here and I cut this into one, that wasn't very even. So let's say here's 1 hour, 2 hours and a half. So 1 hour, 2 hours, and half of an hour. It wants to know how fast he hiked every mile, or when he was, so how fast it took him for the first mile, how fast it took him for the second mile, and this last one here. So if all I do is subtract 2.5, then that just took off 2.5 miles off his hike. And all that's telling me is he hiked 2.5 miles less. And that's not what he did. He hiked 6.1 miles in 2.5 hours. So I need to take the total that he hiked, 6.1, and I'm going to divide it by the hours, 2.5. So 2.5 is going to go on the outside and 6.1 goes on the inside. That's my dividend divided by 2.5. We want to make this a whole number though. So I'm going to make this 10 times bigger. So I need to make this one 10 times bigger. So I'm actually doing the problem 61 divided by 25. But because I did the same thing to both sides of both parts of the problem, I'm getting the same answer. So lists of 25 is pretty easy. It's like quarters, 25, 50, 75. So I know 25 can go into 61. It can't go into the 6, but it can go into 61 2 times. 2 times 25 is 50. And when I subtract, I'm left with 11. So we can keep on going, and we can say that he has this answer as a fraction, or we can put it as a decimal. And I think since we were already working in decimals, we should put our answer in decimals. So I can add this decimal here, and I can add a couple zeros back behind. This is still 61. Adding zeros after the decimal doesn't change my number. So I can bring this down. So let me keep going here. So 25, 50, 75, 100, 125. So remember, 25 is like quarters. So this goes in there 1, 2, 3, 4. That's too big. So 4 times. 4 times 25 is 100. Then we're left with 10. Bringing down my 0. 25 goes into 100 perfectly 4 times. So every mile took 2.44 2.4. Here's our answer here. So if in an hour, this is saying he hiked 2.44 miles. In the second hour, he hiked another 2.44 miles. And in the last one, he hiked half of that, 1.22. And when I add those all up, I will get 6.1. So every hour, I said that backwards, every hour he hiked 2.44 miles. Let's go complete task 2 here. So which statement explains if he is right or wrong? So decide if he is correct or not. And then tell me, how should we do that problem? What did we do to solve that problem? How many miles he hiked every hour? And then tell me, how do you solve word problems? What do you do to help figure out if you're using the right operation or not? So go ahead and complete task 2 and pause the video and come back when you're ready to do task 3. Hey, task 3 says a mole is a standard unit used in chemistry for measuring large quantities of very small objects such as atoms. Mole, like molecule, atoms. If you've been listening in your science class, we've been talking about that. So 1 mole of hydrogen atoms has a mass of 1.0079 grams. So hydrogen has this. 1 mole of oxygen atoms, so a group of oxygen atoms, has 15.9994 grams. And a mole of hydroxide, so to make hydroxide, we need 1 hydrogen, which was 1.0079, and 1 of these, which was 15.9994. What is the mass of hydroxide? Sorry, those bells keep going off. So we've got this word and. To make hydroxide, I need this and this. So when I have hydroxide here, that means it's made up. So this whole thing is hydroxide. And I am using a mole of hydrogen and 1 of oxygen to find the total. So I need to put these 2 pieces together to get the total. So that means we need to add. When we add, we need to make sure our decimals are lined up. So I'm going to start with this 1 here. So 1.0079. So in the ones place, in the oxygen mole, is the 5. So this 5 should be under the 1 in the ones place. Whoop, then my decimals are lined up. Then I have 9.994. So all the places are lined up. And then I don't want to forget this 1 I have in the tens place over here. So now I can go ahead and add those up. So go ahead and try that and come back when you are ready to check. So 9 plus 4 is 13. So 9, 10 plus 7 is 17. 9 plus 1 is 10. 9 plus 1 is 10. I'm going to bring my decimals straight down. 5 plus 1 is 7 and 1. So the mass of hydroxide is 17.0073 grams. So let's go ahead and answer the problems on task 3. So which operation did we use to put those together? And then you're going to tell me the problem you did here and the final mass. And I want you to think, if you can think of a way we could check our work, and tell me how you would check your work here and explain that to me. Hey, then come back when you are ready. Hey, the final thing I want to do today is make a short little list of words I look for when I am solving different operations. So I know when I'm adding, it might say the word sum. I might see the word and. I need this and this. It will ask usually for a total, and it gives the pieces. So those are some helpful things. Oh, that got really small. So those are some helpful words there when you are trying to add the words. So let's get some for subtraction here. So when we're subtracting, it might ask for the difference. It might ask for a piece of it. It will often give the total. I'm going to add a word over here. So it will ask for the total on the sum. So this one will give us the total and it will ask for a piece. It might ask how many are left over. It might say the words, how many more? Or in this one, than this one. Than is another word. We're comparing the differences there. So those are some words I look for when I'm subtracting. So then let's move on to multiplication. So when I'm multiplying, the answer is called a product. And some things it might say is we might hear the word times. How many times this? Or it might say each or every or per. It did this every time. So when we see repeated addition, we know we want to multiply. Another word we sometimes can see is the word of, but we've got to be careful with all of these words though, because just because it says that word in the problem doesn't mean that that's what you do. So I know sometimes there are division problems that will say of, and you've got to decide and help draw a picture, and we'll practice this some more to decide which one you should do, if you should multiply or divide. Okay, so let's talk about some division words here. So when I am dividing, I know some words I might look for is the quotient, or if it's asking for a remainder, that might tell me I need to divide. If it's putting things into equal groups, and sometimes I can even, that word per can be on a dividing problem as well. Repeated subtraction is division. The word of can be there as well, or each and every. So when we are dividing and multiplying, we really have to think about, do I want my answer to get bigger or smaller? Am I making groups of something, or am I doing the same thing over and over again? Sometimes I do the problem wrong, but I have thought about what I might want my answer to be. And I might know, oh, I need my answer. So let's go look back at one of these problems here. So looking here, I know I needed my answer to get smaller because this is how long the hike was. And I wanted to see how fast he hiked every hour. And he couldn't hike 9 miles in an hour if he only went 6.1 miles. So I knew my answer needed to get smaller. And my picture here helped me think about I needed to find every hour's miles. So if I would have multiplied, I would have ended up with a number around 12. 2 times 6 is 12. That wouldn't have made sense if he hiked 12 miles in 1 hour, but he only hiked 6 miles total. That just doesn't make sense. So I can try the other operation. So remember, think about what is reasonable for your answer. And then if that doesn't make sense, try something different. Hey, let me know if there's anything I can do to help you with this assignment.